Hi everyone. Today we're going to study system of linear equations and we're going to solve this by graphing. The graph of a linear equation is a line. Each point on the line is a solution to the equation. For a system of two equations, we will graph two lines. Then we can see all the points that are solutions to each equation. The point of intersection is the solution of the system of linear equations. When we solve a system of two linear equations by graphing, there are three possible cases. Case 1 is intersecting lines, as we can see on the figure. The two graphs intersect in a single point. The coordinates of this point give the only solution of this system. Since the system has a solution, it is consistent. The equations are not equivalent, so they are independent. Case 2 is parallel lines, and our figure here shows parallel lines. There is no solution common to both equations, so the solution set is null and the system is inconsistent. Since the equations are not equivalent, they are independent. Case 3 is the graphs are the same line. And in this figure, we can see one line, but it represents both graphs of both equations. Because we have just one line, there are infinitely many solutions. This type of system is consistent because there is a solution. The equations are equivalent, so they are dependent. Let's have an example. Solve the system by graphing. The first equation is 2x plus y equals 7. The second equation is x minus 2y equals 6. Our step 1 is to graph the first equation. So this first equation we will copy here, and then let us find the intercepts. For y-intercept, we set x equals 0. Thus, the equation 2x plus y equals 7 becomes 2 times 0 plus y equals 7. And we can cancel this 2 times 0. So we can now have y equals 7. This is the value of y when x equals 0. So the ordered pair of y-intercept is 0, 7. For x-intercept, we set y equals 0. Thus, the first equation now becomes 2x plus 0 equals 7. We can ignore the 0 here, so we have 2x equals 7. Let us find the value of x. Let us divide the whole equation by the coefficient of x, which is 2. So we have now x equals 7 over 2. This is the value of x when y equals 0. And let us write the ordered pair of x-intercept as 7/2, or we say 3.5, 0. Now, let us draw the line. Let us plot the intercepts. The x-intercept is the point where the line touches the x-axis. So this point 7/2, 0 is this point. While the point 0.07, this is the y-intercept, the point where the line touches the y-axis, and this is the point. And then let us connect these 2 points by a line. So this line here is the graph of the first equation. Now let's go to step 2, and that is to graph the second equation. Let us copy the second equation here, and then let us find the intercepts. For y-intercept, we set x equals 0. Thus, this equation x minus 2y equals 6 now becomes 0 minus 2y equals 6. We can ignore the 0 here, so we have this negative 2y equals 6. Let us find the value of y. Let us divide the whole equation by the coefficient of y, which is negative 2. And if we do that, this negative 2 will be deleted from y. So we have now y equals 6 over negative 2. And when we simplify this, we will get the value negative 3. So the ordered pair for the y-intercept is 0, negative 3. Now for x-intercept, let us set y equals 0. Thus, this second equation, x minus 2y equals 6, now becomes x minus 2 times 0 equals 6. And this 2 times 0 can be cancelled out. So we have now x equals 6. Let us now write the ordered pair for the x-intercept. So we have here 6, 0. Now let us graph the line for the second equation. First, let us plot the 2 points or the intercepts in our rectangular coordinate system. So we have first the x-intercept is 6, 0, and here is the point, and the y-intercept is 0, negative 3, and this is the point. We connect these 2 points by a line, and this line now is the graph of the second equation. So step 3, determine whether the lines intersect, are parallel, or are the same line. In this example, the 2 lines intersect at the point 4, negative 1. And this is the solution. Can you see here? That is the point of intersection, which is 4, negative 1. And this is our final answer. Example 2. Solve the system by graphing. 3x plus y equals negative 3. 2x plus 3y equals 5. Let us graph the first equation. We have this 3x plus y equals negative 3. Let us find the intercepts. Let's begin with the y-intercept. We set x equals 0. So the equation here becomes 3 times 0 plus y equals negative 3. 3 times 0 is cancelled out, so we have y equals negative 3. We write the point that will be 0, the x coordinate, and the y coordinate is this negative 3. Then we go for the x-intercept. we set y equals 0. For this equation, we have now 3x plus 0 equals negative 3. Or simply we write 3x equals negative 3. We divide this equation by 3, so we have x equals negative 3 over 3, and this is negative 1. And that would be negative 1, 0. X coordinate is negative 1, while y coordinate is 0. Now, let us plot the points and let us draw the line. This is the point negative 1, 0, while this is the point 0, negative 3. Let us connect these 2 points by a line. This is now the graph of the first equation. Now let us graph the second equation. We have this 2x plus 3y equals 5. Let's find the intercepts. Let's begin with the y-intercept. We set x equals 0. This equation becomes 2 times 0 plus 3y equals 5. 2 times 0 is 0, so we have 3y equals 5. Then we solve for y. We have y equals 5 over 3. So the first point is 0, 5 over 3. Then we go for x-intercept. We set y equals 0. So this equation becomes 2x plus 3 times 0 equals 5. 3 times 0 is cancelled, so we have 2x equals 5. Let us solve for x. So x equals 5 over 2. We can write now the point. So 5 over 2, 0. Let us plot these 2 points, then we connect the 2 points. This is the 0, 5 over 3, while this is the point 5 over 2, 0. We connect the 2 points by a line. This is now the graph of the second equation. The step 3 is to look out for the point of intersection, and that is the solution. Look at the 2 lines. They intersect at this point. So we say that the 2 lines intersect at the point negative 2, 3. This is the answer.